All right, here's an alternative way to solve a quadratic equation by completing the square when the quadratic term has a coefficient besides 1. In this case, has a 7 in front of the y squared. Normally, the move is to turn the 7 in front of the y squared into a 1 by dividing all terms inside of the equation by whatever that number is, which in this case is 7. That'll often create fractions, as it will here with the 15. And then once you make the leading coefficient 1, you do the completing the square protocol. But there is a way to postpone the division until the very end so that you don't have to work with any fractions until you get to the last move in the equation. It's a little tricky to do, but it involves the following identity. If you take any binomial squared, and more specifically the square of a linear expression, so like ax plus b squared, and write it out and FOIL it, you'll get a squared x squared. Let me get rid of my video there because it's blocking part of it. You'll get a squared x squared plus 2abx plus b squared, which is really easy to see. All you would have to do is write the parentheses out twice and FOIL it. I'm not going to do that because that's just a matter of doing it. But if you were to write it out twice and FOIL it, excuse me, no square there, you would end up with a squared x squared plus 2abx plus b squared. Now, why is this useful to us? Because we know that you have to look like this in order to factor into something like this. So what do I mean by look like this? Well, let's notice some structural features, and let's also remember that we have complete control over the number that we are going to put in the constant term. In other words, we got to choose the right number to add there. So I'm not too terribly worried about the b squared part because we can add whatever we want there. So what I really want to do is focus on these terms here. So what's so special about those two terms? Structurally, one has an x squared, one has an x, but that's almost always going to be the case. Here, in this case, it's y squared and y. But in terms of the coefficients, there are two things that we can really focus on here. Thing number one, the coefficient of the x squared or the y squared, whatever it is, has to be a perfect square. Okay, that makes sense because it results from squaring this term. But the other thing is that the coefficient of the x has to be twice times the a times some number b. And if we can make both of those things happen, and specifically, if we can make this guy a perfect square, and then the coefficient of the x 2 times that guy, and then some other number there, which once we find out what that number is, we'll know what to put over here, then we can go to town on it. So we're going to take this particular equation, and we're going to try to make both of these things happen. We're going to try to make the coefficient of the x even, and we're going to try to make the coefficient of the x squared a perfect square. All right. So let's fix the fact that this 15 is not even. What's the easiest way to make a number even? The answer is multiply by 2. So we're going to multiply the entire equation times 2. That will fix the coefficient of the x being even. So if we multiply the entire equation by 2, we'll get 14x squared plus 30x equals negative 14. All right, so we fixed the even in front of the x. Now we have to fix the square in front of the x squared. The number currently in front of the x squared is a 14. How can we make that a perfect square? Now remember, we can multiply both sides by anything that we want. The easiest way to turn a number into a square is to multiply it by itself. Sometimes there's a more efficient way to do it, but in this case, times 14 will get the job done. And in fact, it's the smallest number that will get the job done. There's a process that, hold on. There's a process that can find the smallest number to multiply by to turn something into a perfect square. But for now, let's just multiply everything by 14. And if we do that, then we will get 196x squared plus 14 times 30 is, I believe, 420. I'm sure there's a joke in there somewhere. equals negative 196. And at this point, we fixed the two things that we wanted to fix in the thing we're completing the square on. The number in front of the x is even, and the number in front of the x squared is a perfect square. But what number are we going to add here? Excuse me, that was supposed to be a question mark. What number are we going to add to both sides to complete the square? Well, if we go back and look at this, notice that the number that we need to square is whatever would be here if we were to write the middle number as 2 times a times b. Well, what is a in this problem? Well, a is the number that we squared to get the number in front of the x. So in this problem, a is 14. So in order to figure out what the b is, we have to write the guy in the middle as 2 times 14 times something. And then whatever shows up here is going to be the b. Well, we could just take 420 divided by 2, and then divide it by 14, and the number that shows up in there is 15. So that's going to be the b. Now, we don't add 15 to both sides because what we need there is b squared. So the number that we're going to add 15 squared to both sides. 15 squared is 225. So we would get 196x squared plus 420x. 15 squared is 225, so we're going to add that to both sides, equals, and I believe we had a negative 196. We did. Plus 225. Remember, the a was 14 because 14 squared is 196. The b was 15 because 15 squared is 225. That means the left side factors into 14x plus 15 squared. And on the right side, when we add those, we get 29. And now we can just solve using square roots. Square root both sides. Don't forget the plus minus. Can't do anything under the 29. Subtract 15 from both sides. That'll put the minus 15 in front of the plus minus square root of 29. And then divide both sides by 14. So is it easier than dividing at the beginning? Well, that depends on your perspective. It takes a little while to get used to these hoops to jump through to figure out how to turn the trinomial into a perfect square without dividing the number away from in front of the square term, but it'll get the job done.